All right, new unit, thermochemistry. This is about heat, temperature, energy conversions. We're going to do our conversions, or some of them, using dimensional analysis. So same thing that we use with the mole. Told you guys that never goes away. It can be used throughout basically all conversions, whether that's in physics class or in chemistry or even biology or any science or math where you're converting from one unit to another. We use dimensional analysis. So today we're just going to quickly go over like simple concepts of thermochemistry where, I'm just going to kind of tell you them, but really you need to reread over it and learn it on your own. This is one of those things where repetition is going to help so that you learn the new concepts. It's not like math. It's a lot of math involved, but in this particular lesson today, there's not a lot of math involved. It's more concepts. All right, so let's get started. So today I want us to be able to tell what thermochemistry is. I want you to be able to list different types of energy, like the joule or calorie or whatever. And I want you to be able to explain what happens to particles when you heat it up. And you probably have already learned this in physics. But we're going to talk about it today officially, so those who don't have physics will know, and they will be able to be held accountable for it. And then I want us to be able to convert between the units of calories, joules, and kilojoules, the types of energy as listed up here. Thermochemistry, is the study of heat changes that occur during chemical reactions and physical changes of state. So what that means is we're basically studying the change of heat. So that's the unit, is we're going to try to measure heat, okay, and see what happens with heat either during a chemical reaction or if, like, for example, a physical change of state. So for example, ice melting or water freezing, that's a physical change of state, and there is a temperature change involved. So a lot of the chemical reactions we've done this year, I've told you guys, feel the test tube, feel the bottom of the test tube. Is there a change in temperature? Feel the beaker. So that change in temperature is what we are studying this unit. And energy, which you may have learned in physics as well, is the ability to do work or supply heat. These are the 8 different forms of energy that we're going to talk about. Well, we're not going to actually talk about all of them. But here are the 4 different, the different forms of energy. So you have kinetic potential, which you should have heard of if you are in physics or have taken physics. Kinetic is like the energy happening at the moment. Potential is like stored energy. Heat, we know what heat is. Solar is from the sun. Nuclear is from manipulating atoms. And wind, sound, magnetic. I'm pretty sure you guys can assume where these are from or maybe what they will look like. All right, so heat, when we do heat with calculations, you're going to see Q. That's the abbreviation for heat in the equations. And basically heat will go from warmer objects to cooler objects. So if you've ever had like cold feet and you like put it on somebody and your feet get warm, that's your heat. The heat from them is actually leaving their body onto you. It's not your cold is transferring onto theirs. Their heat is leaving to go to yours. So that's what this is saying here. The heat will move from the hot object or warmer object to the cooler object until they are the same temperature, and that's called equilibrium. We're going to do kinetics and equilibrium in another unit. So that's where we're going to stop with equilibrium. All right, so when you add heat, the molecules will move faster and temperature increases. I'm sure the physics teacher has told you that the molecules are actually vibrating faster when you increase the heat, and that's what it's saying here, is that molecules are just moving faster, and temperature is just a measure of heat, and we can measure it increasing or decreasing. All right, and then potential energy is just stored energy. And in this class, we're going to talk about it being stored in chemical bonds. And the amount of heat that can be stored in a chemical bond will depend on the type of atoms and arrangements. So sometimes the energy stored is tremendous, and that's how we can create bombs. And sometimes the heat is very subtle, not a lot of heat is stored, so you don't feel much of a temperature change, if any. Okay, so in a chemical reaction, when you are in the lab and you are mixing chemicals, the potential energy is going to be converted to heat. So before you mix the chemicals, you fill the beakers and they both feel kind of, the room temperature or even a little kind of cold. Potential energy, PE, and then once you mix them together, you feel that it gets really hot. So if your beaker gets hot or if the test tube gets hot, that's considered an exothermic reaction. So if your potential energy is converted to heat, it's an exothermic reaction. Now, there are reactions where heat isn't made. It actually will get cold, and we're going to do some of those in the lab as well, where when you do the reaction or when you mix the chemicals, the beaker will actually get really, really cold instead of hot, and that would be an endothermic reaction. So in lab, we're going to do some of these so that you can feel it and maybe hypothesize whether it's going to be an endothermic or exothermic reaction, and then you can kind of, based on your data, conclude whether or not it was either of them. All right, so law of conservation of energy just means, again, a lot of this stuff is physics, so you may have heard this already. Energy can't be created or destroyed, only converted from one form to another. So here's our units that we will be using in this class. We're going to use the joule, the calorie for chemistry, okay? So you notice that this is a lowercase c. And then the calorie for food. So 1 food calorie equals 1,000 of our chemistry calories, okay? And 1 chemistry calorie, okay, will equal 4.184 joules. So today in the first lesson, the example that we're going to do and what you're going to do in your homework is you're going to convert between calories and joules a couple of times. So how many calories are in joules? That's just a simple dimensional analysis equation. We're going to get a known, which the known will be what the question gives you. The unknown will be how many calories. And notice that that is a lowercase c, so how many calories. So basically you put your known here, and then you're going to have to put the known down here at the bottom, and then your unknown will go up at the top. Okay, so this is just a conversion unit. We're here at our units, and so we're done. So the joules will cancel. You just take 287 divided by 4.184, and you've got your answer. So that's it. It's not too difficult. One other step that might happen is you may be asked for kilojoules. You may not be asked for the joule specifically. So in that case, you're just going to do your known and unknown. You'll have your known, which is this many calories. Your unknown will be here. We know joules, so we're just going to have to take one more step and make it kilojoules. So our known, and then we need to cancel out our known with the calorie here. For every 1 calorie, it's 4.184 joules, okay? And then we have joules as our unit, so we're okay with that, but we need kilojoules. So then we just have to put joules down here and kilojoules up here, which will be the same as grams, kilograms and grams, okay? So for every 1 kilogram, it's 1,000 grams. It's the same with joules, okay? Kilo just means 1,000. And then you plug it in your calculator and you have your answer. All right, we're just going to do a couple of the problems. These shouldn't take long. It's just simple dimensional analysis. So I'm just going to, I guess, pick some at random. So 444 joules into calories. So then you have a known, which is 444 joules into unknown will be how many calories. So we're just going to set up the problem and then type in our calculator, and it's pretty simple. All right, so our known always will go first. I did not mean to write that, sorry. So 444 joules. Okay, so we need to convert to calories. So for every 1 calorie, if you'll remember, you will have 4.84. I think so. So 4.184 joules. Okay. So for every 1 calorie, you'll have 4.184 joules. And that's it. We're at the calories. So just type it in your calculator. So 444 divided by 4.184. And your answer is you have 3 significant figures, so 106. So joules cancel, 106 calories. Let's do one where we'll have a couple of steps. I want to do this one, but there won't be room. Let's do it anyways. Yeah, this will be a couple of steps. All right, so kilocalories into kilojoules. So we have our known and unknown. So we have 0.41 kilocalories to kilojoules. Okay, so we'll write our known, which is 0.41 kilocalories. First, we need to convert to calories, right? I will need more room. All right, so to convert to calories from kilocalories, so that should be a lowercase c. So for every 1 kilocalorie, we should have 1,000 calories, right? Because kilo is 1,000. So we have 1,000 calories, or we have calories, so calories will go here. So for every 1 calorie, we have 184 joules. Okay, but our answer is not asking for joules, it's asking for kilojoules, right? So that means we need to put for every one kilojoule, we have 1,000 joules. Just remember, a kilo means 1,000. If it said milli, which we probably won't be doing, it will be, 1,000 millijoules over 1 joule, whatever. Okay, now we just take this and 0.41 times 1,000 times 4.184 divided by 1,000. And some of you are probably asking, but miss, we have 1,000 twice. We have, significant figures, 2 significant figures, so we're done. Kilojoules. There we go. So for those of you who are good at math, you notice that, hey, these would have canceled out. Can I just skip that part? Yes, that's fine. If you're good at math and you understand, like, this would cancel, that's okay if you're confident that you won't mess it up. I am never confident that I won't mess up a math problem, so I usually set it all the way up and even do that, especially when it really counts, like when I'm making a video.